Today we're going to start a new topic. We're going to talk about polynomials for a little while, and we're going to start with the easiest way to work with them, and that's just adding. But before we even get to that, let's just talk about polynomials for a minute. So sometimes in problems you see an expression like this, 3x to the fourth minus 2x squared plus 12x minus 14, and that's what we call a polynomial. Now, polynomials are made up of what we call terms. This particular polynomial here has four terms. We have 1, 2, 3, and 4. The 3x to the fourth is the first term, the 2x squared is the second term, the 12x is the third term, and the 14 is the last term. And they are all separated by either addition or subtraction. And that's how you know they're two separate terms, because they are separated by either a plus or a minus. So if you see something like this, I give you an example of a very complicated term. So I said a term can have many variables. And my example is negative 13 m squared n to the fourth p. You might look at that and think, oh, that's more than one term. That's got three variables. It's got to be like three separate terms. It's not, because they're all connected by multiplication. They're all basically stuck together as one thing. That counts as one term, even if it has a lot of variables in it. If there was a plus or a minus anywhere in there separating it, that would make it two separate terms. Okay, so let's go back to our original polynomial. The first term was 3x to the fourth. Here's some vocab I want to make sure you guys know. The number part, the 3, that's what we call a coefficient. Now the x part is a variable. That's an easy word. We use that all the time. And the 4 is an exponent, or sometimes we say power, x to the fourth power. Now variable and exponent, you guys know those words for sure. Coefficient, probably. But I just wanted to go over those with you and make sure we're going to use those words a lot as we're talking about polynomials. And if I'm talking about a coefficient, I want to make sure you know what that means. Now, that brings us to the concept of like terms. We have terms, and then we have like terms. Now, like means alike. It means they're very similar. And very specifically, what it means is they have the same variable and exponent, the exact same. So here's an example of two like terms, 12x cubed and negative 4x cubed. When I look at the coefficient part, I have a 12 on the first one and a negative 4 on the second one. Those are different numbers, but that doesn't matter. That's not what we're talking about right now. What we're talking about right now is the variable part. This one is an x cubed term, so is this one. As long as those two things are exactly the same, then they are what we call like terms. And that's important because that's going to lead into our main thing for today. When we're talking about adding polynomials, which is the work we're actually going to do today, all you're doing is combining like terms. You're looking and matching up. You're saying, I got an x cubed term here and an x cubed term here. Let's add them together. I got an x to the fifth here and an x to the fifth here. Let's add them together. So when you're combining like terms, you always leave the like part the same. The variable and the exponent stays the same. You basically just add up the coefficients. So for example, if I have 3x to the fifth plus 7x to the fifth, those are like terms. I can add them up. Now notice the like part was x to the fifth. That's the same as my answer. That's what I meant when I said leave the variable and exponent part the same. You don't add there. It doesn't equal 10x to the 10th power. You don't add the exponents there. You leave that part. What you add is the coefficient part. I say I have 3 of these things plus 7 of these things. It ends up equaling 10 of them. So I started with, think of the x to the fifth as a thing. I have 3 of them plus 7 more of them. I now have 10 of them. I have 10x to the fifth. And that's combining like terms. Now, the one thing I do want to mention is if you don't see a coefficient in the problem, it means there's a 1 there. like an x by itself is 1x. Or in this case, I said x squared plus x squared equals 2x. Well, the reason that's true is because even though you don't see it in the question, this x squared is actually 1x squared. This x squared is 1x squared, and 1 plus 1 is 2. So I get 2x squared. Or you could also do it with a negative. So let's say I had negative x to the fifth plus 4x to the fifth. And I go, all right, well, those are like terms. They're both x to the fifth, so I can add them together. Well, this negative in front actually means negative 1. You have negative 1 x to the fifth. So once you realize they're like terms and you add them together, you say I have negative 1 plus 4 would be positive 3. That's why in my answer I ended up with positive 3x to the fifth. All right, so let's wrap it up with a quick example. Here's our polynomial addition question for today. We're going to add these polynomials. So I have 5x squared minus 2x cubed plus 14 plus, and then I have x cubed plus 10x minus 3. So what we want to do is just combine like terms. And what I like to do is start with the very first one. I have a 5x to the fifth here. Now I'm going to go look at the second polynomial, and I'm going to see if there's an x squared term there to combine it with. Now there isn't, so that means the 5x squared just stays part of my answer. And what I'm going to do, I like to cross them out after I've used them to make sure I don't miss any. Okay, then I have a negative 2x cubed, and I look for an x cubed over here. I have an x cubed, which means positive 1x cubed. So when I combine those, I have negative 2 and positive 1. That gives me negative 1x cubed. Now, after you've used them, remember I like to cross them out just to make sure I don't miss any. Okay, the next one is the 14. The 14 combines with the negative 3. No variables at all, those are like terms. 14 and negative 3 would be positive 11, so I'll put a plus 11. Cross those out. Now see, if I hadn't been going through and crossing them out as I used them, I might miss this one over here. This plus 10x right here, I might forget about that one if I hadn't been crossing them out. But because I'm crossing them out as I use them, I go, oh yeah, I don't want to forget that one. There's still a plus 10x, and since there's no common term to add it to, it just stays part of your answer. Now this is perfectly good for a final answer, or sometimes we like to put them in what's called standard form, where you go from highest power of x to lowest power of x. So then, if you wanted to put it in standard form, remember this is kind of extra, you don't have to do this, but it would be negative 1x cubed, and the other thing is I could just call it negative x cubed, I don't even need the 1. And then a positive 5x squared, so we'll put plus 5x squared, and then a plus 10x, and then a plus 11. So these are both right. It doesn't matter what order the terms are in, as long as you have all the correct terms. The bottom one is called standard form, when you go from highest power of x down to lowest power of x, but it doesn't have to be like that. The yellow one was perfectly fine too. They are both correct answers. But that's what adding polynomials is. It's just looking through the polynomials, finding the like terms, and combining them.